I welcome you to today's class as we continue our study on electricity. Today we are going to look into the production and bulk transmission of electrical energy. Now, there are only about 3 objectives we want to cover, then we close the class. The first thing we want to know is, why is electricity produced for household and industrial use in form of alternating current and not direct current? Number 2, we need to explain why bulk electricity is transmitted over long distances at very high voltages and low current. Finally, we should compare and contrast the overhead power transmission to the underground power transmission. Let's quickly get into objective number 1. It's very important for you to recall and know that industrial electricity and household electricity are produced in form of alternating current and not direct current. The key thing is we need to justify why. So the first objective is to explain why electricity is produced for household use in form of alternating current and not direct current. Let's quickly try to answer this question. There are 2 reasons why this happens. The first thing we need to understand is AC can be stepped up, alternating current can be stepped up or down, but DC cannot be stepped up or down. So the major reason we make electricity in form of AC and not DC is the concept of stepping up and stepping down. Right, here is my production plant where we are producing electricity. Here is my production plant. Along the way, some energy is lost in form of heat. So we'll be losing energy due to transmission. Heat will be generated and electrical energy will be converted to heat. So we need substations where we are going to do what is called step up, stepping up to cater for the losses. So we need step up transformers. Then when we come to consumers, this is your house where you need to use electricity. We are getting to consumers with very, very high voltage. So we have very high voltage in the line. So we need to do what we call step down. Your TV needs about 240 volts, but the line coming to you is in the excess of kilovolts, if not megavolts. So we need a step down transformer so that it suits the requirements of the gadgets in the house. And this is possible with AC and not with DC. Why? I'll explain this when I'm explaining how a transformer operates. When we come to electromagnetism, and I'll talk about how a transformer operates, you will see why we can step up or down, we can alter AC, but not DC. The second reason you need to understand is AC can be easily converted to DC. Probably your phone has a battery. All batteries and all cells are DC. But in your home, you have sockets which are being supplied by AC from this statement here. How are you going to charge your phone? You need an inverter or a converter to convert AC from the port to DC. This is possible with AC to DC conversions, but DC to AC it's not possible. So the 2 major reasons we transmit our electrical energy in form of AC is: number 1, AC can be stepped up or down. Number 2, AC can be converted to DC, but that is not possible with DC. So let's go to objective number 2. Objective number 2 required us to understand, number 1, that electricity is moved over long distances as high voltage and low current. Two very important properties. Bulk movement of electricity involves high voltage and low current. The question we need to answer now is, why is it transmitted as a high voltage and low current? Now, there are two major reasons which I'm going to deal with. You can find other reasons elsewhere, but I'm going to concentrate on two major reasons. Number one, it is to minimize energy losses. Number one is to minimize energy losses. It increases efficiency. Having high voltage and low current increases the efficiency. How does this happen? Current flows along the wires, and we know that as current is flowing, there is resistance leading to generation of heat, what we call ohmic heating. So if we've got higher currents, we're going to experience more resistance, which generates more energy, causing more losses of electrical energy. So a lower current will reduce the ohmic resistance and the ohmic heating, reducing the energy losses in form of heat. This is the reason number one, very, very important. Let's look in the second reason. The second reason is economical. Now, for us to transmit very high currents, we need thick cables. Remember, thick cables can carry more current than thin cables. Since we're transmitting very high currents, we need a thicker cable and not a thinner cable. There will be overheating here on a thinner cable. So if we transmit our electrical energy as high voltage and low current, you'll probably use cables of reasonable thickness. This reduces the copper being put into the cable, which consequently reduces the cost of installation and the cost of transmitting electricity, which in turn reduces the cost of the electricity. So the major second reason is economical. The lower current that accompanies a high voltage reduces the resistance of the conductor, meaning thinner cables can be used, lightweight cables can be used over long distances. This reduces the cost of transmission cables, which in turn lowers the cost of electricity. This is the major thing. But you can find elsewhere some reasons, like it reduces the mass of the overhead grid. That's true. If the cables are lightweight, it means the center of mass is not very high, which makes the national grid a bit stable. But I want to dwell on the cost of electricity. Thinner cables can handle a smaller current. So the less current which accompanies a high voltage allows for the use of a thinner cable, which reduces the mass of copper used, which in turn reduces the price. So that becomes economical considerations. Right. Now, activity number 3 or objective number 3 required us to compare and contrast overhead power transmission and underground power transmission. I will leave you, as we take a commercial break, I'll leave you looking into this question. When you come, I'll present a table with the solution to this question. Enjoy the activity. Welcome back. We are going to compare and contrast overhead power transmission to underground power transmission. So here is a table which I made for comparisons. During your own time, you can find time to write notes, make notes from the table, even increase it if you can find others. Do more research, but this is what is expected of you when you're comparing and contrasting overhead power cables to underground power cables. Until we meet next time, enjoy a day. Your senior coach Chigo here, signing out. See you then.